Don't let this happen to your planet. Presented by Science at NASA. Ozone stinks. People who breathe it gag as their lungs burn. The EPA classifies ground-level ozone as air pollution. Yet without it, life on Earth would be impossible. A fragile layer of ozone 25 kilometers above Earth's surface is all that stands between us and some of the harshest UV rays from the sun. The ozone molecule O3 blocks radiation, which would otherwise burn skin and cause cancer. On Mars, which has no ozone layer to protect it, solar UV rays strafe the surface with deadly effect, leaving the apparently lifeless planet without the simplest of organic molecules in the upper millimeters of exposed Martian soil. To keep track of our planet's ozone layer, NASA is about to launch the most sophisticated space-based ozone sensor ever, SAGE 3, slated for installation on the International Space Station in 2014. The ISS is the perfect orbit for SAGE 3, says Joe Zawodny, project scientist for the instrument at the Langley Research Center. It will be able to monitor ozone all around the Earth during all seasons of the year. SAGE 3 works by using the sun and moon as light sources. When either one rises or sets behind the edge of the Earth, SAGE 3 analyzes the light that passes through Earth's atmosphere. Ozone and other molecules absorb specific wavelengths that reveal their density, temperature, and location. SAGE 3 is essentially analyzing the colors of the sunset to track ozone, says Zawodny. It sounds romantic, but this is hard science. Researchers began to worry about ozone in the early 1970s, when University of California chemists Sherry Rowland and Mario Molina testified before Congress that man-made CFCs, a key ingredient of common aerosol sprays, could destroy ozone in the stratosphere. In 1985, researchers with the British Antarctic Survey announced abnormally low ozone concentrations above Halley Bay near the South Pole. Our planet had an ozone hole, and it was rapidly growing. In a remarkable display of international cooperation, an ozone treaty was negotiated only 2 years later. The Montreal Protocol regulates the production of CFCs and other ozone-destroying chemicals. First signed in September 1987, it has since been ratified by every member of the United Nations. Because of this agreement, ozone is now on the mend. Ozone holes still open every year above the South Pole, but thanks to the treaty, ozone-destroying chemicals have either leveled off or decreased. At this rate, the ozone layer could recover almost fully by 2050. To ensure that ozone really is recovering, NASA has been flying ozone sensors in Earth orbit for decades. The first of the SAGE sensors rode to space on Earth-observing satellites in the late 1970s and early 80s. SAGE 2 data helped confirm the decline of the ozone layer and measured the effect of the Mount Pinatubo eruption on the stratosphere. A SAGE sensor on board the Russian Meteor 3M satellite extended the ozone record into the 2000s with higher precision than ever. Zawodny is eager to learn what SAGE 3 finds in the lower stratosphere over the tropics. The recovery of ozone there is tied to changes in greenhouse gases like CO2. Given what we know about recent increases in greenhouse emissions, it is possible that ozone in the tropics will never return to 1980s levels. SAGE 3 probes Arctic regions too. Using the moon as a light source, SAGE 3 can detect ozone during the darkness of polar winter where other satellites have trouble seeing. It's enough to make a hard-nosed researcher wax eloquent. Images of the moon and sun rising and setting are dramatic and spectacular. The interplay between the source of light and the environment delights the senses and stirs the imagination. The ability for SAGE 3 to turn those perceptions into something meaningful is a great pleasure. In other words, get ready for some beautiful ozone data. For more information on SAGE 3 and our atmosphere, stay tuned to science.nasa.gov.